Assalamualaikum warahmatullahi wabarakatuh. Today I would like to present about our previous assignment, which is we need to build a microstate table and also determine the electron transition for our UVVs for metal complex. Okay, so first, in order to build a microstate table, we need to calculate the charge of the metal complex. So you can see my metal complex in the screen behind. So we have here is Na, and the charge of Na is +1, and for C2O4 the charge is -2, and as for H2O is a neutral ion, so the charge is 0. So we need to sum up all the equation, and we will get nickel equal to +2. And after that, we can see that nickel is in group 10 in the periodic table. So we need to minus the charge with 2. So D10 minus D2, so we will get D8. So for the second step is we need to calculate the probability. So the formula for probability is n factorial over e factorial times n minus e factorial. So n stands for maximum number of possible orbital positions, and for e stands for number of electrons to be placed. So since we are doing for d orbital, so the maximum number of possible orbital position is 10, and for e, since I am doing d8, so the e is the number of electrons is 8. So after the calculations, you can see my calculation in the screen behind. So I got 45 as the possibility. So after that, I need to draw all the 45 probability as you can see in the screen behind. So it is my drawing of the electron positions for my metal complex. And after that, we need to calculate the value of L and S in order to build our microstate table. And as you can see in the screen behind, I already calculate the L and S. So the value of L is 4, 3, 2, and 0. And as for my S, I got 0, -1, and 1. So this is my microstate table that I got from my previous calculation, and also all the probability. As for the ML and MS and everything, I already put that in the table behind on the screen, as you can see. And as for the last part, we need to determine the transition in the UVVs. First of all, I will fill my 8 pair of electrons in the orbital. So after that, I'll use the formula n+1, and n is stand for number of unpaired electrons. So I have 2 unpaired electrons, so 2 + 1 equal to 3. And after that, I need to calculate the value of L, which is I got the value of 3. So 3 stands for F state. So we got the ground state equal to 3F. And after that, we need to refer to the Tanabe-Sugano table for 3F. And as you can see behind, for my UVV spectrum, they have a few peaks. For 376 nanometer, the transition is from 3A2G to 3T1G. And for the 650 nanometer, the transition is 3A2G to 3T2G. That's all from me. Thank you.